Good evening, everyone, and welcome again to Dream Career Talk Show. Dream Career Talk Show is about building your dream career, which is much beyond getting a job. Here on this show, we are going to have industry experts coming from various domains who will be sharing their knowledge, their experiences, their challenges, their failures, and success so that it can help others in their career journey. This show is to help corporate professionals expand their context, get clarity, direction, hope, inspiration, and of course, the right steps to build their dream careers. While many of them are running behind the software jobs in the IT industry, there are some people who are working on their dreams in the semiconductor industry. Not many understand the kind of opportunities that are there in the semiconductor industry, be it great opportunities, the ever increasing demand, or the kind of money people can earn in this industry. The opportunities and demand have always been increasing. C has been something people have been hearing and learning from ages. While C++, Java, scripting, Python, there have been many other languages that have come in, but C has its own advantages. How to grow in the field of embedded systems engineering? What are the skills required? How is this field growing and how does the future look like? To understand all of this, we have today's conversation with someone who comes with 20 plus years experience in the field of embedded systems engineering, and he has over 10 years experience working in the leading semiconductor companies. Our today's guest, Prakash Kamliya, is a principal engineer with a leading semiconductor company. Prakash, very happy to have you
Hey,
here on Dream Career Talk Show.
hey, Fada. Thank you a lot for giving me this opportunity on this Dream Career Talk Show. I'm really grateful for that. Thanks for inviting me in this talk show. How
Yeah,
are you doing?
I'm doing great, and I think the kind of engineers, the distinguished engineers, the principal engineers, when I see in various top companies, I believe most of them have your kind of persona, right? The IT field or whatever, humble, always ready to share the knowledge, but yes, some a little introvert, right? But focused on work, passionate about your work. So very happy to have you here, Prakash, and I'm sure that it's going to add a lot of value to our audience today. So why don't we get started with your career journey?
Yeah, sure. So, if I talk about my career, I started my career around 2000. So, I completed my Bachelor of Engineering in Electronics and Communications in 2000, and then I started my career in the job. So initial 1 year I spent on the automation software, um, and then later I moved to the one of the leading technology product based company in the market of EPABX and embedded systems. So basically the network routers and those kind of stuff they were making, and I entered into that domain. And yeah, so there almost I spent maybe around more than 7 or 8 years into that domain, like making the product from the scratch. Actually, when we make the product, embedded product, so that is not only the software. So we have the hardware, we have the software, and we get a touch on the enclosure also. So when you build the product, you need the shape for that product, the real product. So that is the benefit of working with the small and startup kind of company. So there you get exposure to the different domain within the product based company. So there almost I spent mostly around more than 10 years into that field, and I learn about the hardware, learn about the software, firmware, DSPs, algorithms, and a lot of things I learn. And I also mentor the team, maybe more than 10 or 20 engineers throughout my career uh, into that domain. And then later I switched to the semiconductor domain. So almost maybe 10 years before I joined the Qualcomm India Private Limited, who is the leading smartphone chip manufacturer. Basically, they build the chip for the mobile devices, the SoC. Now they call it a system on chip. So I entered into that domain, and then now I'm working with one of the leading semiconductor company. And right now I'm focusing on the graphics technology, which is, which is, you can say it is close to the embedded, but it is completely a lot more than the embedded systems. So I'm focusing on that part right now, and I'm working as a principal engineer. And yeah, so throughout my career, I led a team of multiple engineers, and then I learned a lot of technology things, and then drive the product, release the product, and making the software, and a lot of things I got a chance to work on during this career path.
Great. And good to see the journey. And when we are talking to the technical guys, right, the technology part is always shown there. So good to know about your journey. And one question here is, since I also come from the IT industry, and I see a lot of people running behind the IT industry, right? And there are some like you who have been in the semiconductor industry, and then you have been living your dreams. Now, this happened accidentally, or was it something by your choice?
Uh, it was kind of my choice. So, so it was kind of my passion. So if I talk about my passion, um, when I was around maybe 15, 16 years of age, and I started developing interest towards the electronics things. Like those days, we had the televisions. Televisions were new into around maybe 1990 or something around that time. Television were new, and then I started developing interest toward those things. So I used to stand, in nearby house, we had one television repair shop. So I
Okay.
generally go there and used to stand there and watching how the technician is repairing those TVs, whatever the TVs is coming. So I was curious about those things. And later, in fact, I joined the television repair course also during that time, and learn about the circuit, and learn about the different component of the electronics, and figure it out, okay, how they are working. Not in that detail, but at a very high level. And luckily I got a chance to get admission into the engineering in the electronics field. So I decided I wanted to go into the electronics field, and that is how I got a chance to get into the engineering field also, and that is how I started my career. So in fact, it is more about the passion instead of passion and interest toward the software and the electronics. So I was curious like how these things are working, and how that thing is working, and that led me to into that domain. So that is how I started my career. Yeah, in fact, in those days, during the college time also, I was not having the computers at my home. So I used to spend, my father used to spend around 300 rupees per month. I was going to the cyber cafe. I was learning about the programming. A daily 1 hour I go to that cyber cafe and do just C programming and those kind of stuff during those days. Yeah, so that is how I developed my interest, and I was very much passionate about this field, and then I started my career into this field.
Wow, inspiring here and interesting to know the journey that started from watching the television repairs, learning that television repair, and getting into the semiconductor industry. And today you are like holding one of the distinguished roles, which is like principal engineer, right?
Yeah.
Principal engineer is similar to like we have distinguished engineers in different fields. Like I've been into the network companies where we have the similar positions here. Did you ever imagine, Prakash, that you would be able to code and you would be able to become one of those who are like coding today the latest technologies when you started your journey?
When I started my journey, that time I was not having the clear clarity, okay, where I'll be going. But slowly, my curiosity and my interest toward the new technology that really drove me to this level. So that is how generally I learned a lot of things throughout my career. So the very like the most thing is about curious, because see, whatever the thing I know, if I don't know, I generally go how this is working, and then I go deeper, and then learn about those things. So it is, in fact, it is building the foundation stone for the next technology. So that is how I started my career and learned a lot of thing about that thing. Yeah,
Good,
my
good to
friend
know that.
joined this talk.
Digesh Pandya is saying
Yeah.
good going, Prakash. Yeah. So, so nice, nice to see this. And now, Prakash, you started into this, and this industry is like a combination, right? Here, you need to understand a lot of electronics, the chips, and all of that. Plus, you need to know the programming. Now, there is a lot of things that goes on here, right? Uh, was it complicated for you from the beginning, or because your passion you were able to like start discovering from the beginning? Like, what were the challenges in the initial stage, if you can think about?
Initial stages, it was like learning a lot of new things. In fact, that is the current challenge also, because technology is ever changing. So every day they are coming up with a different chip. So if I talk about the semiconductor industry, maybe 3 or 4 months they are coming up with a different chip. So all the hardware, so sometimes they re-architecture the hardware. So you need to cope up with those kind of changes. So you need to learn a lot of things during your career path also. So that is the biggest challenge. But initially, I mean, one thing I was lucky, like I got a good mentor initial years, maybe after 1 year or 2 years. So my boss in my previous company, I would say he was the great mentor for me, and I learned a lot of things from that boss. And then usually we sit together, and we like used to program together. And then my boss was telling, okay, this is how we should design the system, and a lot of things I learned from my boss, previous boss. So that really helped me a lot to shape the career into this system designing. So that really helped me a lot into building up the complete system knowledge. So okay, not only the mentor, but yeah, along with the mentor, we also need to put our effort. So I put both the things, and then I developed those kind of uh, yeah. I learned about lot about the technology during those periods, and that was the foundation for the upcoming technology. So once you have the clear foundation, all the fundamentals are clear about the circuit, about the hardware, about the software. For you, it is, I mean, once you know all this foundation, it is very easy to learn the new technology. So that is how, I mean, initial days, in fact, initial days there were not much ecosystems in the software industry. So it was more kind of the assembly language. You need to write some code into the assembly language. So those days, I mean, I have written the code in the assembly language also during those days. And slowly people were moving towards the C programming into the embedded domain during those days. So that was the challenge. So I mean, working in the assembly language, which is like pretty close to the hardware. So that
Yeah.
is the like thing.
So good to know that you were able to get this mentor early in your life, and especially your boss becoming that mentor, right? Not everybody is fortunate enough there. So do you think the role of mentor to lay that foundation helps? Like, if somebody gets a mentor early in their career, do you think that will help them?
Definitely, that will help. The reason is like, see, I mean, if you are in the early career, so you may not have that visibility about the technology. You may not, your perspective will be limited. So you may not think beyond that perspective, why we are doing this, why we should not do this way. So those kind of questions, I mean, you can always get answer from the good mentor. So I would suggest like uh, to get a to get a good understanding on anything, better to be in touch with the mentor who are more knowledgeable than you. So that is how you build the knowledge, and then that is how they expand your scope. Otherwise, you will be limited within your domain only. You will not have the visibility outside of your domain. So that is really important to have the mentor in early careers. That is definitely is important.
Yeah, and I know the way you think about it, and the way you are trying to give back to society by going to some colleges where you help students understand about the future and the kind of careers here, right? So that is
Yeah,
really good job that you are doing out there, and I
yeah.
know you
I,
are
I
mentoring some people's out. Yeah, go ahead.
yeah, I want to talk about that thing. In fact, recently my one of my relative son is studying into the engineering, and then I mean, generally what happens in the education like engineering, it is not the applied learning. Like they go through the theory, they don't talk the real world problems. So then I started, okay, let me give you one introduction about the object oriented concept, and how can you make the software so that you can use that software into the devices. And then when I started teaching about those things to that student, in fact at the end of that session he told, okay, you should be in the teaching industry. That is the compliment I got. So because he was not able to connect whatever they are learning with the real things. So that is how the missing part in the current education system is. So it is, I mean, it is very important for the people who are working in the industry for the long time to give back to the society whatever they have learned. It is better to give back to the society so that this complete society can be you can make a growth
Transform.
into the society. Yeah,
Hmm.
transform. Yeah.
Yeah, and very well said here because I think I completely agree with the kind of education in terms of the theoretical knowledge that goes on.
Yeah.
And I would say I was one among those, right? Running behind the theory knowledge, even during the corporate world. I don't feel shy about it, where I was also struggling because theory cannot help you until unless you don't get into the practical ground. And someone who has experienced, like you or others who are doing good, it's always good to get connected with mentors, understand the technology, understand the principles, and then get started with it. So that's
Yeah.
really good. And you also spoke about assembly level programming, right? And
Yeah.
when you spoke about that, I could recall one of the subjects that I had studied during my engineering called microprocessors. And at that time this elevator program was the one which was like very popular. So do you want to talk about how assembly level programming, or is it the same, or is the technology changed today, like when the elevators are being used, the way elevators operate and all of that? How is embedded
Yeah.
systems being used there?
Yeah, so the embedded system, like, yeah, Rohit put some compliment for me. Thank you, Rohit. Yeah, so for the embedded systems, I mean, if I talk about the embedded systems, earlier days, it was like now there are two different part in the embedded system. One is having the operating systems, and the other is without operating system. So if I talk about the embedded system, like we have the wrist watch, that smart watch, or that activity band. So generally they are the non-OS platform, and they have the very limited memory, very limited space, and very limited processing power. So there we cannot put the complete operating system into those kind of devices. So those are very small devices in terms of the form factor, in terms of the resources. And the other domain which is now trending, like the inference engine, the machine learning processing is happening on the edge devices nowadays. So you need a lot of computing power, you need a lot of memory, you need a lot of power, and you need a lot of energy also to run your logic into those devices. So now it is like very small segment where you have the small kind of chip, and the other is a kind of big trending toward the, which is very close to the now mainstream processor. So there are two different domain as on today in the embedded market, and both domain are really doing, I mean, growing fast. I mean, both has a like their benefit into their domain. So there are two different domain in the embedded market.
Okay, and
Yeah.
now we have been talking about the C language. When it comes to embedded, we talk about C language, right? Right, and we know today there are so many other programming languages, be it like the C++, Java, Python, or any other language you talk about. What makes C the language which is like still the preferred language for embedded systems engineering, and how it takes advantage of over the other platforms or the languages?
Okay. So C language, it's kind of very close to the hardware, I would say. So it gives you the free hand to talk directly to the hardware. I mean, if I do do the same thing on the Java, it is very difficult. You cannot directly talk to the hardware. There is no way. I mean, you need some abstraction layer, and then you go through that layer, and then you talk to the hardware. But when it comes to the C programming, it is very flexible, and I mean, you have the free hands. Whatever the things you want to do directly, if you want to talk to the hardware, you can talk. That is the like the flexibility of the C hardware. C programming. The second thing is that the whatever the program we write, so that is more efficient in terms of running the logic. Let's say if you run some program and on one processor, it might be taking say 1 second. If you write the program into the Java, it might be taking 1 second. But if you run the similar program on the C, so it will take maybe half of that processing time. So within 500 milliseconds, you can finish those things in the C programming. And the second thing is on the memory also. So in terms of the memory, in terms of the processing power, you are very close to the hardware and you can achieve a lot more things within the given time and within the given memory, because embedded system is very tightly, I mean, you don't have the flexibility of lot of memory. If I talk about the laptop processor, we have almost around 16 GB RAM, and few GB hard disks, like 1 TB. Now we are talking about TB. But in the embedded systems, you might hardly have few KBs. Sometimes like smartwatch may not have more than 1 MB memory, and couple of other embedded systems may not have more than maybe 4 GB memory. I mean, if I talk about the phone nowadays, they are coming out around maybe 8 GB or 16 GB memory nowadays. But earlier it was limited to the 2 GB, 1 GB, those kind of things. So I mean, in case of embedded system, we have a lot of constraint in terms of the processing power, in terms of the memory, and that is the reason it is best to program into the C. But there is a disadvantage also programming into the C, because I mean, it you need a lot of hands-on coding into that. So if you go to the higher level programming like the C++ or the Java, you get a lot of inbuilt library, and the same thing whatever you are trying to achieve with the C++, maybe you can achieve the same thing within few lines of the code. So that is the benefit of the high level programming. But when it comes to the memory, when it comes to the power and power saving, when it comes to the processing, fast processing, it is generally all the algorithm like they are very generally written into the C programming, the low level programming. So that is the reason generally the C is like most popular into the embedded system. And nowadays, slowly, people are moving towards the Python also. Python at maybe for the prototype purpose, not for the like mission mode software, but for the prototype, generally they go with the Python nowadays. Like Raspberry Pi. Raspberry Pi is one of the platform, which is the embedded platform. There you can write the code in the Python and you can run it on the device. So yeah, so but C is the top number one choice for the embedded programming. Generally, if I talk about the operating system for the embedded system, so if I talk about the Linux kernel, so that is completely written into the C. Yeah, so that is mm,
Good,
it's
good to
very
know that. And you were talking about how in smartwatch there is only like 1 MB memory, and then you are interacting with that. Now, can you pick up
right.
an example of the smartwatch here and help us understand like how embedded systems, right, or how this particular field is helping in these kind of technologies? What happens here?
Yeah, so if I talk about the smartwatch, basically you need the display. You need to show something. You need display. You need touch point because you're giving some input. You need to set the time, or maybe you want to see your how many steps you have done today. So what is your they need to track a lot of things. They are tracking nowadays the sleep
Hmm.
tracking and step tracking. A lot of things are happening. So it needs CPU, it needs the display, it needs the communication with the mobile, because you have to install some application on your mobile. So within that tiny chip, you have a lot of things. You have the display, you have the memory, you have the CPU power, you have the communication protocol, you have the communication chip, which is talking to the Bluetooth with the mobile phone, and everything tied in a single chip. And you have the limited resources. And yeah, so that is how generally the embedded systems, everything is tied into the single chip. And then, I mean, for the user, it may not notice, okay, a lot of things going on into that system. But when you work on this kind of devices, you will realize, okay, how complex that small chip is. Yeah, so a
Hmm.
lot of things goes into that, even the small chip. Uh, if I talk about the mobile size may be few millimeters only, and the chip size, but it has a lot of processing power within that chip.
Great. And what about the latest technologies, like when we are talking about, say, drones and machine language, artificial
Yeah.
intelligence, all of this? Can C still be used here? Because I keep hearing about Python is being used for machine language, machine learning, and all of that. So, how can C be used here, and what is the role of embedded systems?
Yeah, so here nowadays the embedded system is growing. Like earlier days, we were having the limited processing power, limited memory. Nowadays, like we have the memory in terms of the GBs and processing power. Like your processor might be running at 2 GB, 2 gigahertz frequency, and it will have the multiple core running. So now the it generally we call it as a SoC, system on chip. So it has a lot of inbuilt component, the subsystem like the video processor or the graphics processor. You have the network processor, and you have the memory subsystems. You have the interconnect, which connects all of this peripheral to the CPU, and a lot of things are going. So that is we call it as a SoC. And SoC, I mean, if I talk about the programming, it depends like at what level we are writing the software. So the software is layered. So on the top, you have the application layer. So generally, you will be writing the code into the Java. If I talk about the Android device, Android mobile, so generally whatever the application we write, like even if I open the Gmail or the Facebook, whatever, so the user interface which we are getting, that is written into the Java at a high level. But when it talks to the hardware, it goes through the different layers step by step. So the top layer generally is written into the Java, and then it talks to the intermediate library, so which is generally written into the C++ programming, C++ or any other intermediate library. And then comes the driver layer, the driver layer, which is generally either C or C++. And then comes the OS layer. So everything below the OS is all C programming, but everything above OS can be C, C++, Java, Python, anything. So it is not like only C is being used into the embedded domain. It depends at what level we are talking. Is it, are we talking about the application level? Then definitely it will be the little higher level language, because it is difficult to write the complete application into the C programming. But if I talk about the device driver, which directly talk to the graphics processor, or which directly talk to the video processor, so those drivers are generally written into the C programming.
Hmm.
And
So basically, yeah, go ahead.
yeah, sorry, go ahead.
So basically, when you're talking about application layer, there you have any preferred language that you're using, maybe like
Right,
Java or
right,
anything. When it comes to the underlying layers, that's where like C is mostly used. Now you
right,
were talking
right,
about Android, and we also have iPhones, right? So all of
right.
these have different operating systems. How like embedded systems is being used in these kind of technologies, because they have their own operating systems, right? Is still the embedded systems being used here? How is the
Yeah,
chip design and all of that?
mostly, yeah. So the mostly for the embedded systems, like the big embedded system where you have the luxury of more, like lot of memory and the processing power. Generally, it is it is just the flavor of the Linux operating system. If I talk about the Android OS is one of the variant. You can say the variant of the Linux operating systems only. So Android completely is running on the Linux operating systems. Even the iPhone, which is also underneath, it is running on the Linux operating systems. So may not be the direct Linux, but they need to tweak that OS so that they can tune the operating system according to their hardware, according to their peripheral. So it is I would say it is the flavor of the Linux operating system. So everything is running on the Linux nowadays. Like even the smartwatch, like the iPhone smartwatch, it is having the Linux operating system. So it is based on the Linux operating systems. Even the Android phone, Android smartwatch we are getting, like the maybe 10-20K, depends on the what kind of watch you are buying. All the watch is Android watch is running on the Linux operating system. You may not
Hmm.
realize, okay, it has complete operating system running into the small watch. So that is the trend nowadays. A
Yeah,
lot of
for
things
us,
are
we
going
will
to
just see
the
the application layer, or we see the topmost
right.
layer, right, where things are maybe just Android or iOS and all of that. Now,
Yeah,
when we are talking about electronics, right, we always talk about chips. Semiconductor industry, we talk about chips, right? So, is chip involved in all of these devices, like be it drone, be it
right.
your watches, be it your laptops? Everything runs on chips.
Definitely, definitely. So if I talk about the autonomous car driving,
Hmm.
let us take that example as a like just for the understanding. So autonomous car driving, I mean, if we drive the car, right, we need to like control the steering. We need to change the gear. We need to put our leg on the clutch and accelerator. A lot of things. So same thing now. Everything is done by the machine or chip, whatever you call it. So it has the control. It has the control to control the fuel, and you need to control the brake. You need to control the steering. How much I should turn my steering, and along with this, all this control, you need reason because see, autonomous is something without man. The car is driving. You need a reason. What is coming on the road? Is there any obstacle or not? What is the current signal light? Am I in the right track? Am I in the right lane or not? I need to detect the lane. Okay, I'm going into this lane. This is my speed. Behind my car, the other car is coming, and this is the distance. Lot of things we need to do, and we need to do a lot of synchronization between this all of this thing. So definitely you need a lot of sensor for this. You need camera, you need lidar sensor, which is generally to know the distance and how far the object is. And you need a lot of control, like you need to control the motor for the steering, and accuracy is also important. Even 1 mm you want to steer the steering, it is like it has to be accurate. So a lot of things going into this background. You need a lot of sensor, you need a lot of control logic, and then you need a lot of power because see, the car might be running very fast, maybe 100 kilometers per hour. Your speed might be 100 kilometer per hour, and you need to detect a lot of other object coming into your path within few microseconds. So that is the lot of challenging task for any embedded systems. So yeah, so all of these things is nowadays are based on the machine learning. So they train a lot of data set. Based on the data set, they do a lot of processing on the embedded systems, and you need a lot of power, you need a lot of processing to do all this kind of things. Also we need to synchronize each other. So object is coming, you need to put a brake. Object is far away, you speed up the things. So there is a lot of synchronism going behind the scene, and that is really a complex thing. So that is how generally the embedded systems generally is a complex domain, and it is difficult to learn sometimes. But yeah, but if you are passionate about the things, and if you are really curious about the things, definitely we can do it. But there is a lot of synchronization, lot of software getting involved, even each domain within this subsystem, like the autonomous subsystems. So you may not be working on everything, so you may be focusing on the one part. in the overall subsystems. So there will be a different team who is working on the video, there will be a different team who is working on the camera subsystems or the video subsystems. Like this, there will be a different team coming up with their software. You need to integrate all of that thing, and then you need to test it, you need to verify it, and then you need to do the final testing. A lot of things going on behind the scenes when we just see, okay, this is the autonomous car, but if you really look at the background story, the technology, the software, the hardware, there is a lot of complexity going behind the scene. Yeah, so it is interesting and complex also.
Complex, interesting, exciting. For me,
Yes,
definitely it is complex. I will have to like confess on this, because electronics was one of the toughest subjects for me, right? And I don't know, maybe I was not passionate about that subject. But here, what we understand, Prakash, is there is a lot of integration also happening, right? On the software
right.
side, the application layer, right? You are writing the high level, you are like writing the code in C, C++, Java, right? Different ways, and also there is an interaction or the integration that is happening with the hardware, the operating system, right? And you spoke about synchronization, and also like the data analyst role in terms of the
Right.
right,
Machine
that is
learnings. Yeah.
also very much here. Now when we are going back to the hardware, right, and we are looking at c or embedded systems, can I call it as the backbone for anything?
C is the backbone, I
Hmm.
would say, because C is the topmost programming language. If you don't know C, then you cannot work on the embedded system. That is, I would say. So C fundamental, I mean, should be very strong. If anyone want to learn about the embedded systems or go into this kind of domain, a semiconductor industry, the C is the first thing they should focus on. So C is the backbone, and learning about the computer architecture, because see, hardware, you need a lot of like you need to know a lot of things within the hardware, because the hardware itself is not a single piece of like single piece. It has a multiple piece joined together, and then you are making one complete chip. So you need a lot of understanding on the computer architecture, how the CPU is working, how it is connected to the memory, and what is the CPU frequency, what is the power, how it is connected with the different peripheral. So at least computer architecture fundamental should be clear. And on top of that, if you have the little bit understanding on the how this VLSI and VHDL code is written, so that nowadays like everything is in the VLSI, that VHDL and Verilog programming language for the hardware. So just get a hands-on basic understanding about those things, so that you come to know, okay, this is how the the chip is designed, and then you learn about the C programming, computer architecture, hardware architecture. Those are the very basic thing for anyone who wanted to build a career into the embedded system.
Hmm.
So this is the
And
very basic thing.
yeah, and we see one the thing in the outside world. There is always a hype of the IT industry, the software engineers, and all of that, right?
Right.
And I also come from the IT field, but don't you think it's the electronics part which drives the everything, be it the IT or anything, right? The laptops are based on the chips, the mobiles,
Correct.
the smartwatches, everything. So can we call it like the electronic engineers are really the backbone and the IT engineers maybe the front end facing there?
Definitely, you can tell because everything is running in the chip. So even if we talk about laptop or whatever you are running in the cloud, cloud is everything is backbone with a lot of servers, lot
Mhm.
of cloud servers. So they have a lot of GPU power running, GPU, CPU, lot of things running in the backend server. Everything is running on the hardware. So definitely it is everywhere. You can say the semiconductor is everywhere. So even like our headphone or the mic, whatever we are talking through,
Interesting,
it's
interesting. Right. So there are like the real heroes sitting in the background and doing a lot of stuff like you. I think that's amazing. Be it the latest technologies like the drones you were talking about, automated, the autonomous car driving, all of this. I think that's really interesting to know about all of these.
Yeah, so nowadays, like the other field in the embedded system is the IoT, Internet on Things. So those are like kind of the flavor of the embedded systems. Like you have the CPU, you have the network power, you have the connectivity with the network, and then it has the sensor, lot of things going, and then it is sending all that data to the central server and a lot of IoT devices. Even the autonomous car driving and aerospace defense, a lot of things are still on the lot of semiconductor things. It's a completely vast domain. Embedded system is uh, ever evolving. Uh,
Right, interesting. And but there is a strange thing that I have noticed here. Though I don't think we can generalize here, but I have seen a lot of electronic engineers jumping into the field of IT and then getting into like software domain of it, right? Rather than looking at the hardware or the electronics domain. What do you think are the kind of opportunities in the electronics field or in the semiconductor industry, in the embedded systems field that people can look for?
so opportunity wise, there is a lot of demand, in fact, but the real challenge is the industry, semiconductor industry. It is very tough to get a talented guy. I mean, who is very strong in the C programming, who is strong in the system knowledge. So that is very really tough to get someone. But if I talk about the opportunity, there is a lot of opportunity. I mean, all the semiconductor companies, you talk about the AMD or like the Intel, Nvidia, and in the communication that chip, we have the Qualcomm, and those are the big company doing the semiconductor. They are in the semiconductor industries, and there are other consumer market also like the Apple or the Dell and HP. So those are kind of the semiconductor, but they are not into directly into the semiconductor, but they are the consumer market. So there is a lot of opportunity in the semiconductor market, but the real challenge to get job into the this industry is like nowadays the people are learning more on the like HTML, CSS script, and those kind of things. But there is not much focus in the industry to motivate someone to get into the semiconductor industry. So that is somehow I think it is missing, and that is what I'm trying to bridge the gap. I'm as little as I can. Yeah, so I mean there is a lot of shortage of the talent, quality talent, in the semiconductor industries. And nowadays, I mean, you might have heard about the current news. There is a shortage of the chip in the market because of like COVID hit in the China, and then there is a completely shortage of the chip, and all the semiconductor prices are going up. And there is a lot of even if you book the car nowadays, I mean the lead time is very much. You might get maybe after 6 months. The reason for that is because there is a shortage of the chips in the market. They are not getting the chip which they can fit into the car. So because of this thing, what happens, the lot of industries are now moving to the different geographical region other than the China. So they are focusing on the India as well. So I mean, you might have heard about the Tesla is going to set up some development or the setup into the Bangalore, nearby Bangalore. Tesla is coming with the Starlink, also is one of its subsidiary, Starlink. They are also coming up with their setup into the India. So nowadays, the lot of trends are exploring the other geographical region, and I see there is a lot of opportunity within the India also in the semiconductor business. There is a lot of opportunity. Only thing is, yeah, someone who is passionate about these things, who love the hardware, who want to work with the hardware, who want to work with the close to the hardware software. I definitely, I mean, if you are interested and if you learn those things, definitely you can get a job into the semiconductor industry.
Yeah, good to know the kind of opportunities you are talking about here, right? Where in the semiconductor industry. The demand is there, and we also hear about the talent, right? Difficult to find the
Yeah,
talent. And is that the reason maybe why people in the semiconductor industry or in the embeddeds like maybe earn double, triple from the IT typical software engineers?
definitely, definitely. The reason is there is a shortage of the talent, and there is a lot of demand, a lot of need of the resources, but you have the shortage of the talent. Yeah, definitely higher than the normal IT industry. Definitely, you can get a higher pay scale other than the normal IT industries. IT industry, if you go into the market and let's say if you search for any guy who is like doing the web designing or the HTML, if you ask 100 guys, maybe you will find 60, 70 guys who can do that web page designing and the HTML designing, those kind of things. But if you ask, okay, I mean, who are the best embedded engineer or the talented embedded system level engineer, you will hardly find maybe 10 out of 100, 10 or
Hmm.
7. So it is like that. So because of
Yeah,
that, the pay scale also will be higher, and everything
right.
is everything is driven by the semiconductor industry. So you talk about the big name in the technology. So they are the Apple, they are the Microsoft, they are the Google is also coming up with their own chip for the mobile phone. So they already launched, I think they are already launching the new Pixel phone based on their chip. So even the Facebook is working on their own design chip. uh, AMD is anyway is working. I mean, it has a lot of good CPU and GPU. And then Intel, there is a lot. If you talk about the big technology name, mostly you will find mostly in the semiconductor industries.
Hmm. And what kind of skills should somebody be learning? Like just C, or is there anything else? Like if somebody wants to enter into this industry?
C programming is the very basic thing. I would say it is the KG, senior KG. I mean, you go to the senior KG, junior KG. So that way I'll be putting, and that is the very first step, C programming. But along with the C programming, I mean, you should be very strong at the problem solving, because embedded system is not just the one little small area. So you need a lot of knowledge to the other domain also. So apart from the C programming, we need to, I mean, we need to build a strong programming skill, logic, coming up with the logic to address the problem solving skill, debugging skills. Those are the very important skills. And I mean, to develop these skills, you need a lot of understanding on the hardware also, because until and unless you don't understand how the hardware works, you cannot fix those kind of problems. So debugging, problem solving, and the C programming skill is the very basic thing in the embedded domain. If someone is building the skill set on this very basic thing, I'm sure like anyone, any language they can learn. So if you give them the C++ or if you give them the Java, HTML, they can definitely learn about those things. So that is the foundation, I would say, foundation skill for anyone who wanted to get into the embedded systems.
Hmm. So I think there's a lot of scope for both IT and electronics
Definitely.
engineers into this field. The
Yeah.
condition being like learning C and also having that problem solving skills, the debugging skills that they can develop,
Yeah.
right? Getting started with
The,
those.
the challenge in the embedded systems is like you don't have that infrastructure for the debugging. You need to go to the low level. Okay, single stressing, execute single instruction, see the output, those kind of stuff. Sometimes like based on the systems, but nowadays that is also evolving. But you have very limited debugging scope also. So you need to come up with some different idea how can you debug those kind of problems. So that is challenging in the systems.
Yeah, but over a period of time with the practice and working on the systems, I think
Definitely.
people can build that, right? And as you
Right.
rightly
Right.
said, having that passion in that industry, right, will take them places.
That is the driving force. So if you don't enjoy the things, then definitely you will not be in the industry.
Right. And you have been just some time back when you were talking about CPU, you also spoke about something called GPU. Now, I have been hearing about GPU, and at times I have heard terms like TPU and all of this. Like, what are these, and are these the advanced technologies, or were they already existing? What is this all about?
Uh, at a high level, if I talk about the CPU generally we talk about the cores. We have the 8 core, 6 core CPU and those kind of things. But let's say if you wanted to do some gaming which involves a lot of processing, so you need a lot of parallel processing going on. So which you cannot achieve on the CPU. So you need a lot of concurrent, the same program running on the different data set at the same time. So that kind of architecture you need. So that is how why we have the GPU. So GPU generally they will have tons of parallel core running the same program but different data set. So you need a different for the different kind of the data set. You need a different kind of the computer architecture. So if I talk about the games, all the games are like anything you are seeing on the screen. Even if you open the Google map, so it is driving all that roads and connecting all that roads. Everything is done behind the scene by the graphics processor unit, because CPU cannot do those kind of processing within the given time. So that because CPU architecture is completely different, GPU architecture is completely different. And if I talk about nowadays the machine learning things, like the artificial intelligence or the machine learnings, they do a lot of matrix multiplications. So, I mean, we learn about the matrix multiplication in the college days,
Right.
but right now I'm learning. Okay, this is how this really is useful into the industry. So when you actually work onto the machine learning, what is the machine learning? It is just about the like you have the lot of data coming, you multiply with some number and then you add some number. So that is generally we call it as a convolutions or the matrix multiplication. So if I talk about the TPU, which is they call it as a tensor processing unit, that is specifically designed to do all these matrix multiplications within the short period. So it has a complete different architecture compared to the GPU, compared to the CPU. So based on your problem area, I want to do the application, I want to develop the application for the machine learning, then TPU could give you the best performance compared to the GPU. Not always, but it depends on the data set and a lot of other factors will affect. So you have the dedicated processor to do all kind of things for the matrix multiplication, for the machine learning. Generally, you offload those things to the TPU. For the graphics, you offload those things to the GPU, and for the normal user interaction, like you click on the mouse and then you are getting the event, you hit a keyboard and then you are getting the event. All these things will be processed by the CPU. So there is a different problem area. All the problem area depends on that problem area. The task is given to the different processing. So it has different architecture for doing those kind of things in the optimum way. So that is how
Interesting.
generally the trend is going, even in the
Interesting.
CPU
Yeah. And when you were talking about you're using matrices, right? Matrix multiplication and all.
matrix multiplication.
It's really good to know because on a lighter note, uh, I think we all spent a lot of time on learning matrix and all of that, and I could never
Yeah.
apply that in my life, and I'm sure a lot of people would not have applied at all.
I mean, same thing happened to me also. I mean, recently I started working on the machine learning things, and slowly I learn, okay, there is a real need of, you need to apply whatever you learn in the college days. Now you need to apply those learnings into the real field. That is how we are connecting. And that is the problem also, because see, if you go to the college, like there is a disconnect with the industry. They don't teach you where you will be using this matrix multiplication. They will not teach you. They will simply say, okay, this is how you do multiply two matrix and then you get the final result. But
Right.
where will be using that matrix, that is the important. There is a disconnect. So definitely, I mean, I'm just trying to bridge that gap as much as I can.
Yeah, that would really help people, especially the students who want to get into this field, right? Understanding how the matrix multiplication and all will be used in future. Right, and we have
There is a
Timothy here adding about
yeah
GPU, right? So thanks, Timothy, adding about the brief description about a GPU and how it can be used. And now we also, I just wanted to touch on the telecom industry now, Prakash. We have 4G, we have 5G. The technology has been evolving, right? And here also we talk about chips. So how is the involvement of like embedded field in this particular telecom domain?
yeah. So for the 5G, I mean, there is a lot of the use case would be the internet on thing. Like and you have a lot of small devices, the embedded devices, but what is the optimum way to connect that devices to the network? And how can you how the each device can communicate together without connecting to the base station? So if I talk about the mobile, for the mobile to communicate, you need the direct connection to the base station, and then from there you are getting the signal and we are talking. But in domain of the IoT, so I mean there is a something called the mesh network. So mesh network. So device can talk to each other directly without going into that network part. So there is like something like drastically will change the complete the way the device are talking. So you might find some of the device on your pathway, and let's say, I mean, I was thinking about one use case, uh, tracking something, right? So you want to track something, so you can nowadays there are a lot of tracking devices are coming. You can put into the car, and then you can track that car. Like because they will be sending the signals to the network using the 5G or 4G connection, and then you'll be tracking those things. But at the granular level, like device to device communications, without going into that base station and then communicating, there is something called the mesh network. They are coming. So with that network, the each device can communicate to the each other. Then they can pass on the. It is like completely building the complete network of the different devices, and you have the complete connected devices. So any device, maybe the device sitting in the US, can talk to the device sitting in the India. So that is how the IoT domain is evolving, and slowly, I think I have read somewhere by 2029, the IoT domain is the market share would be around $1 trillion dollar. So that is
Hmm.
how I mean, slowly people are going into the market is going to the IoT devices. So there actually there is a need of the 5G things.
Yeah.
So for the mass communication.
Yeah, I know. Like it's really like the IoT and everything is going to be the like already that's there, right? And it's going to like
Yeah.
the way you said, it's going to be more or less the future. And here we have, I think, Mahesh also talking about great growing
Thank you,
Prakash,
Mahesh.
your wisdom and experience. I think you have a lot of fan followers because of the value you have added in their lives and being able to
Thank you,
bring up
Mahesh.
with so many experiences. Yeah. So good to see that. And now, Prakash, you have been in this industry for about 20 years, and you are at a very good role now, principal engineer, which is like a distinguished engineer, right? And this is one of the dream or aspiration of many people who get started in the electronics field or even in the IT field, right? So, what is the career roadmap if somebody has to reach that level, right, or go much beyond that? Like, what is the career roadmap in this industry?
Yeah, definitely. So this is important questions for anyone to get into the industry. So the very first thing I generally I tell to the student also. So initial 5 years, you don't look for the salary. You look for the learnings. So if you are really interested into the embedded domain or the system level programming, then definitely you go to the small company where you have a lot of team collaborate. I mean, coming together, they are making the software, they are making the hardware together. You will learn a lot of things, not only software. You will learn a lot of the hardware things. You will learn about the product design. How do you design the product? How do you like make the box for the product? And you will sometimes get a like exposure to the hardware also. So I would say initial 5 days, you go for the company, like maybe small startup or like mid-range company, where a lot of people are working closely together, and then you can like get a lot of perspective apart from the software. Definitely C, C++, and the little bit on the assembly side and understanding about the computer architecture is a must thing. But along with this thing, I mean, that is how generally I suggest. Uh, Go to the small company, learn about a lot of things like what they are doing. Don't limit your scope to the single domain, expand your scope, and you build that foundation initial 5 years. And generally, I mean, for the initial 5 years, you will be titled as a engineer, associate engineer. Generally, in the big company, they start with the associate engineer, and then there will be engineer level, and then maybe after maybe 5 or 6 year, I mean, the second thing is you should be hands-on. It is not like okay, you look at the code and then okay, you understood the code. You should do a lot of hands-on coding, hands-on programming, hands-on debugging. So those kind of stuff is really needed for the initial career days, maybe initial career years, maybe about 7 years or up to that. And then slowly, I mean, you got a hold on those things. Now you're owning something, owning some software, and you are leading that software. So generally, the next career path would be the senior software engineer. In the career would be the senior software engineer. So they will also mentor a couple of maybe one or two folks. Along with that, they will contribute into the coding. They will do the code review. They will design the things, and then maybe after 10 years of the experience, you generally the people go to the lead positions, so where they will lead one or two engineers. Along with that lead, they will also contribute into the software development. They do the code review, they do debugging along with the like different engineers. Yeah, so they are the lead engineer, and then there is a staff engineer. If you go to the MNC, generally they have the level, but this levels varies from company to company. Sometimes even
Right.
if you find the senior software engineer, but internally the level would be different. So that is
Right.
how, like, I would say learn, lead, and inspire. So learn is something like you focus maybe 7 years for the learning, and next 7 year you lead, learn plus lead for the next 7 years, and again for the next 7 years, learn, lead, and inspire. Why I'm not putting the learn? Because if you stop learning, then you'll be stopping your career into the domain, any domain. So I would say learn, lead, and inspire. For anyone to grow into the semiconductor industry, learning is a must.
Right.
Yeah, so this is the
Amazing.
foundation, I would say.
Really, this is really wonderful, and definitely, like you have come through that path of learn, lead, and inspire. And thank you for inspiring a lot of people out there for getting into roles like you are today and getting success in their careers as well. So I think it was a wonderful conversation, and you have been able to give some golden nuggets, especially the last point where you added about the career roadmap. Right, I loved it because I think it comes from a lot of experience where people need to understand the kind of amount of time they spend in each of those segments
Uh,
as well.
one thing I want to add here. Sorry if I'm
Definitely.
taking a few more minutes. Yeah,
Yep,
so
please.
why I force on the initial careers you spend on the learnings and spend like quality time with the startup and small company. The reason is if you go to the big company, there is a like for the there will be separate domain. So you can just focus on the one domain, second domain. So you may not get that visibility outside of that domain. You may not get the opportunity sometimes, and depends on the different situation and the environment. So I mean, before going to the big companies, the large scale company, it is better you build up your strong foundation on the everything, the hardware, software, and like the product designing, and then you go to the bigger company. Then that will add a lot of value into that company also, and definitely you will find yourself as more knowledgeable than the other guys if you're coming up from the those kind of background earlier years. So so that is, I mean, the bigger companies, they have the bigger teams, bigger domain, different subsystems. So there will be an individual group working on that specific domain only. They may not get a chance to look or may not get a chance to look into the other domain. So that is the reason I'm putting this thing.
Yeah.
So yeah,
Makes sense, makes a lot of sense. And thank you for adding so much of value today. And I'm sure people who have been watching us have loved this conversation. Especially thanks to Digish, Rohit, Timothy, and Mahesh for being here
Mahesh,
and encouraging and appreciating this conversation. And for all of the other people who have been watching us, thank you. And for people who are going to watch us later, on different social media channels. Thank you for you too. And this was really wonderful conversation, Prakash. Thank you for being here. And we have certain questions coming in. And what I would recommend is please reach out to Prakash. He's available on LinkedIn, and he would be
LinkedIn, yeah.
happy to help you with your questions there. So please do that. And thank you again for being here, Prakash. And thanks everyone for joining us.
Thank you, everyone, and thanks a lot, Fatah, for giving me this opportunity to talk on this. So thanks a lot.
Yeah,
Have a
it's
good
my
day,
pleasure,
guys.
and thank you again. And yes, everybody who is watching this, stay tuned and continue watching this show because we are going to bring more industry experts so that you can learn from their experiences, their knowledge, their failures, and their success, so that you can work to build your dream career. So, thank you and good night.
Thank you. Thanks a lot.